हेलो बच्चों, आज हम सर्ड इंडाइसेस और लॉगरिथम के बारे में पढ़ेंगे. ओके, सर्ड इज नथिंग बट, ओके, बिफोर वी स्टार्ट द सर्ड यू हैव टू नो अबाउट द रैशनल नंबर and irrational number. So rational number is like the q and irrational number is q dash. Okay, q dash or q complement. So a rational number, if we write anything in the form of, okay, if we write in the form of p upon q, where q is not equal to 0, is known as rational number. And irrational number is like we cannot write in the form of p upon q. Okay, but in the simple way, if I will tell you what is rational number, so the number, okay, the number which is either terminating or the number is recurring. Okay, either the number is terminating number or the number is recurring, then only it is known as rational number. Okay, so for irrational number, okay, for irrational number, non-terminating, non-recurring, okay, so whenever this both the condition is there, then only we get the irrational number. And in this chapter may we'll be studying the surd is nothing but all the number which is non-terminating and non-recurring. Now what is the meaning of non-terminating, non-recurring? If I say 10 divided by 3, okay, what is 10 divided by 3? So if we divide 10 by 3, we'll get the answer 3.333 ... Okay, now you can see here the number is non-terminating. Why? Because it never end here, right? The number is non-terminating, but it is recurring number, but this number is recurring number, so we can say this is rational number. This is what? Rational number. This is rational number. Why? Because it is non-terminating but recurring number. Okay, but if I say what is the value of root 2, what is the value of root 2? People will say, so root 2 ka value is 1.414, but it's not only 1.414, it will be, because we know only till 3 decimal place, it will be goes on number. Okay, and will not get any pattern also here, it will be different number come. So this will be non-terminating as well as non-recurring, so that's why root 2 is irrational number. Same way root 3, 1.732, and then again goes on number it is. Okay, because we have to write only 3 decimal place, so like we remember only this many places, but unless we can get the answer infinite number of times, so this will be non-terminating as well as non-recurring, so root 3 is also irrational number. So in this chapter, in the chapter surd, okay, we'll be studying all this type ka number. So the number which is not a rational number, that type ka number, that is the number which are irrational number. So indirectly we'll be studying about the root 2, root 3, root 5, okay, cube root of 3, fifth root of 7, all this type ka number will be studying in this. Okay, so let's start proper. Okay, so the like we have root 2 and we have root 3. So now in this also we'll get the like, how we have the like fraction, the same way we have the like surd also, the like term. So now this is what is the meaning of root 2 under root 2 or the square root of 2. So this is nothing but 2 raised to half. Okay, same way this is 3 raised to half. So if the power is half or both are the square root, so we can multiply root a into root b is nothing but root of A multiplied by B. Okay, that means if we have root 2 multiplied by root 3, so we can write the answer root 6. Okay, but suppose the first one we have square root of 2 multiplied by cube root of 3. Okay, so we cannot multiply here because they are not like term, so we cannot multiply if it is not a like term, meaning the root, if this is square root, this also has to be the square root. If this is cube root, now suppose we have cube root of 5, okay, multiply by cube root of 7, so still we can multiply because both have the cube root, so that become cube root of 21, cube root of 7 5 is 35, so this will be 35, 7 into 5, that become 35, so cube root of 35. Clear it is? So whenever we have the same root, meaning the square root, if all the term like the root a into root b is equal to root ab, same way if it is more than two terms like the square root of a into square root of b into square root of c, you will get the square root of a into b into c. Same way cube root of a into cube root of b is equal to cube root of a into b. Clear? Same way we can do the division also. The square root of 2 divided by square root of 3 is equal to square root of 2 upon 3. Okay, square root of 2 upon 3. Clear? So we can multiply also, we can divide also, but the condition is what here? They have to be the like term. So you can say root a into root b is equal to root of a into b, and the root of a upon root of b is equal to square root of a upon b. Okay, same way now if they can give any power here, nth power of a raised to nth power multiply by b nth power of b. Okay, nth power of a multiply by nth power of b, the answer is nth power of a into b. Okay, nth power of a into b. Same with the division also, the nth power of a divided by nth power of b. If we divide, we'll get the answer nth power of a upon b. Okay, nth power of a upon b. Okay, now let's do few sums based on this, then we'll go ahead in this. Okay, so root a into root b is root ab, and root a upon root b is root of ab, a upon b, and but if it is plus given, okay, root of a plus b is not equal to root a plus root b, and if it is root a minus b, then is not equal to root a minus root b. Okay, so this formula only work for the multiplication division, not for addition and subtraction. Okay, so now let's do few sums. So now see, whenever you get the sum, this is also square root, this is also square root, so we can directly multiply inside the bracket. Okay, so root 3 into root 27, this become root 3 into 27, that become root 27 3 is 81, and what is the square root of 81? Square root of 81 is equal to 9, so the final answer is 9. Same way, now we have the root 8 upon root 2, so now this become root 8 upon 2, which is equal to root 4. Now root 4 ka value is what? 2. Okay, square root of 8 upon 2 is nothing but the square root of 4, and square root of 4 ka value is 2. Same way we have the root 5 raised to 2. So actually if you see here, this is nothing but root 5 multiplied by root 5, which is equal to root 25, and which answer is 5. Okay, or you can write the formula directly, root a the whole square is equal to a. Okay, root a the whole square is equal to a, right? So the answer for root of 5 square is equal to 5. Okay, next one. Now like the same, we have the two terms, we can multiply the 3 also and more than that also. So now here, but only you have to check properly, they all has to be the square root, all has to be the cube root, means the root ka power has to be the same, because this will be the square root, square root, square root. So we can multiply all the three. So this is nothing but square root of 3 into 6 into 2. So 6 3 ja 18, 18 2 ja 36. So root 36, which is equal to 6. Okay, square root of 36 is equal to 6. Next one is, now only root 12 given and they ask you to simplify root 12. You have to simplify. So what you have to do here, you have to split. What you have to do here, factorize 12. So that is nothing but, if you factorize 12, so you'll get 2 into 6, again 2 into 3. So 12, if you factorize, how to factorize 12? So 12, and then you can do by the 2, 6 ja, 2, 3 ja, and 3, 1 ja. So the factor is 2 into 2 into 3. 2 into 2 into 3. Okay, but now out of that, you can write down like the 2 into 2 and into root 3. We can separate. Now what is root 2 into 2, which is nothing but the root 4 into root 3, and 4 ka value is 2. So the answer is 2 root 3. Okay, means whenever inside the square root a into a is equal to a is the answer. Okay, square root of a into a, the answer is a. So square root of 2 into 2, the answer is 2. So 2 into root 3. 2 into root 3. Same way root 32. So 32 will factorize first. 2 16 ja, 2 8 ja, 2 4 ja, 2 2 ja, and 2 1 ja. How many will get here? 1 2 3 4 5. So that will be square root of 2 into 2 into 2 into 2 into 2. So what we have to do, make a pair. Okay, make a pair of 2 number. So if you make a pair of 2 numbers, so from these two, how we wrote the formula now? Square root of a into a is equal to a. So square root of 2 into 2, so 2 will be outside. Square root of 2 into 2, again 2 is outside, and this root will be as it is. So become 4 root 2. 4 root 2. Okay, square root of 32 is nothing but 4 root 2. 4 root 2. Next one is square root of 1500 divided by square root of 20. Okay, root of a divided by root of b is nothing but, you can do combine only. So that becomes square root of 1500 upon 20. So 0 and 0 get cancelled. 2 1 ja 2, 7, 14 1, so become 5. So it become root 75. Okay, root 75, but still root 75 we can simplify. So we'll take the factor of 75. So 75 first comes in 3 table. 3 25 ja, then 5 ja, and again 5 1 ja. Okay, so 3 into 5 into 5. So this you can write down root 3 into 5 into 5. Now from this will be what? One pair given, square root of 5 into 5, that become 5. So the answer is 5 root 3. Okay, so the answer is 5 root 3. Next one is okay, now this is also one property here, we can add or subtract. Okay, we can add like you can say a root x plus b root x. If the inside the root inside the root if both the values are same, both are square root or both are cube root, then we can add a and b. Indirectly we can take the root x common, so remaining is a plus b. Okay, so we can add or we can subtract also. A root x minus b root x is equal to, again you can take the root x outside, so remaining is a minus b. So it is nothing but a minus b into root x, and here this one is nothing but a plus b into root x. Okay, so we can add or subtract if the root numbers are same. Okay, if the root numbers are same, we can add or subtract. So 6 root 3 plus 7 root 3. So what is 6 plus 7? 13. So 13 root 3 minus 5 root 3. Okay, again root 3 and root 3 both are same. So 13 minus 5, that become 8. 8 root 3 is the answer. Clear? So we can add also same and subtract also, but if the root number is same given, then only. So the answer is 8 root 13. So let's do few more sums. Okay, next one is root 32 minus root 8 plus 3 root 2. Now see, we discussed that formula. If the root numbers are same, then only we can add or subtract. Here the root numbers are not same. This is root 32, this is root 8, this is root 2. Okay, so sometime if they are not in the root numbers are not same, so we'll try to make it same. Okay, now how to make it same here? So we have like root 32. So like previously we just did, 32 is nothing but 2 5 times. Okay, so this is nothing but 2 into 2 into 2 into 2 into 2. Clear? Minus 8 is nothing but 2 into 2 into 2, and this will be 3 root 2. Now we have to make a pair here. So we got the 2 pairs of 2 into 2, 4. So 4 root 2 minus 2. So one pair will be outside. So 2 root 2, and this will be plus 3 root 2. So now all the base are same, root 2 root 2 root 2, so we can add and subtract now. Okay, so if sometime the base is not same, so we can simplify and make it the base same if it is possible. Sometimes not possible also, but yes, here it is possible. So 4 minus 2 is 2, 2 plus 3 5. So the answer is 5 root 2. Clear? 4 minus 2 is 3, 3 root 2 plus 4 minus 2 is 2, so 2 root 2 plus 3 root 2, so 2 plus 3 5, 5 root 2 is the answer. Okay, next one is the multiplication. Okay, now normal algebraic expression where we did the formula for a plus b into c plus d. How to multiply if we have normal sum a plus b into c plus d given, then how to multiply? Okay, binomial multiply by binomial. So what we do here, we take the first term, we multiply the second bracket. Okay, and we take the second term and we multiply by the second bracket, and then we multiply a into c, then we multiply a into d. Okay, then same way here, b into c plus b into d. Clear? Okay, so let's write down that formula again here. So a plus b then c plus d is equal to a open the bracket c plus d plus b open the bracket c plus d, which is nothing but ac plus ad plus bc plus bd. Okay, this is the one formula. Then we need a plus b the whole square, means whatever formula we did in algebraic expression in the normal sum, the same formula we'll use in Surds chapter also. Okay, only instead of the proper number you might get the root number also. So a plus b ka whole square, we have to use a square plus 2ab plus b square. Same way we have to use a minus b the whole square is equal to a square minus 2ab plus b square. Same way we have a square minus b square, which is nothing but a plus b and a minus b. So we have to use all this formula. Okay, after that we you can get the sum a plus b ka whole cube also, which is nothing but a cube plus 3a square b plus 3ab square a b square plus b cube. Okay, so all this formula which already we did in the factorization chapter, algebraic expression and factorization chapter mein, so we have to use the same all this formula in this also. So the first one is we have the two bracket, we have to multiply both the bracket. Okay, so now the same way we have to use the same thing. It's like the a plus b into c minus d given like suppose here. So we'll take the first number 4 multiply the second bracket 9 minus 5 root 3. Okay, and then the second one which is 2 root 3 multiply by 9 minus 5 root 3. Okay, simple it is. First bracket का first term multiply the whole of the second bracket, then the first bracket का second term multiply the whole bracket of the second one. Now multiply, so 4 9 ja 36, 4 9 ja 36. Now 4 into minus 5, so 4 minus 5, 4 into minus 5 minus 20 root 3. Okay, minus 20 root 3, then 2 into 9, so that become 2 9 ja 18, so 18 root 3, and 2 5 ja 10, so minus 10 root 3. Clear? Okay, so now in this we have, wait, 2 root 3 into 9, 9 2 ja 18 root 3, that is right. 2 into minus 5 become minus 10. Now what is root 3 into root 3? So that will be 2 times we have to multiply, because we have the 2 root 3 into minus 5 root 3. So 2 into minus 5 become minus 10. Root 3 into root 3, that is root 3 into root 3, that give you 3 afterward. So we have now 36 minus 20 root 3, keep as it is, plus 18 root 3, keep as it is, minus 10 into root 3 into root 3, that become minus 10 into 3, that become minus 30. Minus 30. So now 36 minus 30, that give you 6. Now minus 20 plus 18, so minus 2 root 3. So that become 6 minus 2 root 3. 6 minus 2 root 3. Okay, so first term, first bracket का first term multiply by the whole of the second bracket, then second bracket first term का second bracket, like the first bracket का second term multiply the whole of the second bracket, and then you simplify. Okay, and then you get the answer here. Now same way we have a plus b the whole square. So again we'll use the same formula, a plus b का whole square, which is a square plus 2ab plus b square. Okay, so a square plus 2ab plus b square. So in this case it become 4 square plus 2 into 4 into 3 root 2 plus 3 root 2 the whole square. Clear? A square plus 2ab plus b square. What is 4 ka square? 4 into 4, that give you 16, plus 2 4 ja 8, 8 3 ja 24, so 24 root 2 plus 3 का square 9, root 2 का square 2, 9 2 ja 18. Now 16 plus 18, 8 plus 6 14, 4 carry 1, 1 2 3, 34 plus 24 root 2. proper. 4 का square 16, 2 4 जा 8, 3 जा 24, 24 root 2 and 3 का square 9, 9 into root 2 का square is 2, so 9 2 जा 18, 16 plus 18 that give you 34 plus 24 root 2. Okay, this is of multiplication. So we can do addition also, we can do subtraction also, we can do multiplication, we can do division also, but division will be a little other way here. Okay, so instead of the division they say rationalize the denominator. Rationalize the denominator means whatever the number given in the denominator, like here this number is what? Irrational number. Okay, this number is what? Irrational number. So they want in the denominator a rational number. They want in the denominator rational number. So if in the denominator only one number given, okay, so we multiply and divide by the same number. We multiply and divide by the same number because only one number given. So now if you multiply, you will get 3 into root 2, that is nothing but 3 root 2. And in the denominator, root 2 into root 2, that give you 2. So the answer is 3 root 2 upon 2. Our main target is what? Keep the denominator a rational number. And 2 is what? 2 is rational number. What is 2? 2 is rational number. So we have to rationalize the denominator. So for simple thing, if the denominator has only one term without plus minus, so we multiply and divide by the same number. Now the other sum, here again we have to do the same thing. What we have to do here? Rationalize the denominator. But here we have more than one term. We have two terms given in this, 3 minus 5. So whatever they give in the denominator, we take the conjugate of that. Okay, conjugate of that, meaning a plus b ka conjugate is what? A plus b conjugate equal to what? A minus b, meaning whatever the sum they given, the same thing with opposite sign. Here 3 minus root 5 given, so we multiply and divide by 3 plus root 5. So into 3 plus root 5 upon 3 plus root 5. Okay, so now this become 8 open the bracket 3 plus root 5 upon, now we have a minus b, a plus b. What is a minus b, a plus b? That give you a square minus b square, which is nothing but 3 square minus root 5 square, that give you, so this will be multiply 8 into 3 24 plus 8 root 5 upon 3 का square 9. Okay, minus root 5 का square is 5. So 9 minus 5 is nothing but 4. So instead of doing what you can do in the beginning now, don't multiply, just keep as it is. Okay, so here we multiply, so don't multiply, keep as it is the numerator. So we'll get 8 3 plus root 5. Okay, and the denominator will be 9 minus 5, that give you 4. So 4 1 ja, 4 2 ja, and then you multiply 2 into 3 6 plus 2 root 5. Clear? It's like if you do here also, then again you take the 4 common and then you can cancel the remaining answer. You get 6 plus 2 root 5, meaning here 24 and 8 may you take the 4 common and 4 in the denominator, so get cancelled. So remaining is 6 plus 2 root 5. So the answer will come same only, but this will be more simple. So in the beginning may don't multiply, first you check the denominator whatever is given. So if it is cancellation, then you can cancel, and then whatever remaining you multiply with the denominator. Okay, next one is, now we have the numerator and we have the denominator. We have to rationalize the denominator. So whatever given in the denominator, the same we did here. We have to find the conjugate of the denominator. So here it is 2 root 3 minus 3 root 2. So we'll take the opposite sign. So we multiply and divide by 2 root 3 plus 3 root 2 upon 2 root 3 plus 3 root 2. Okay, so multiply and divide the conjugate of the denominator. So conjugate is what? If it is a minus b given, so it become a plus b. So we multiply a plus b both. Means whatever you multiply in the numerator, the exactly same you have to multiply with the denominator also to balance the equation. Okay, so now the numerator will be 4 root 3 multiply the 2 root 3 plus 3 root 2 minus 3 root 2 multiply by 2 root 3 plus 3 root 2. Clear? The first term multiply by the second bracket, then the second term multiply by the second bracket. Okay, and the denominator is a minus b, a plus b, so it is a square minus b square, a square minus b square. So now this become 4 2 ja 8, root 3 into root 3 is 3, so 8 into 3 24. Clear? Now 4 3 ja 12, so it become 12 and root 6 because 3 2 ja 6, which can't simplify, so as it is. Now 2 into minus 3 become minus 6 and root 2 into root 3 is 6, so it become minus 6 root 6, and minus 3 into 3 that become minus 9, root 2 into root 2 that give you 2, whole thing upon 2 का square 4, root 3 का square 3, 4 into 3 that give you 12, minus 3 का square 9, root 2 का square 2, 9 2 जा 18. Clear? Okay, so now this become 9 2 ja 18, 24 minus 18, 24 minus 18 that give you 6, 12 root 6 minus 6 root 6, so 12 minus 6 will be 6, so 6 root 6 upon 12 minus 18 is minus 6. Okay, 24 minus 18 is 6, 12 minus 6 that give you 6, 12 minus 18 is minus 6. Now take the 6 common in this, or you take the minus 6 common. So if it, okay, just take the 6 only, so 6 open the bracket 1 plus root 6 upon minus 6, this get cancelled, so remaining is minus 1, so minus open the bracket 1 plus root 6, you can write on this, or minus 1 minus root 6. Okay, this is your answer. Minus 1 minus root 6 is the answer. Okay, now they can give the same type ka sum but in word problem also. Like they given here, a triangle has base 8 minus 4 root 3 centimeter and area 9 plus 4 root 3 centimeter square. Okay, find its height in the form of a plus b root 3 centimeter, where a, b are rational number. Okay, so they had given a triangle whose base given, area given, and they ask the height. Okay, meaning suppose this is a triangle given, right? This is the height, this is the base, and they given the area also here. Okay, they had given the base, they asking the height, and they had given the area. So any formula you know, area of a triangle where the base and the height is given. Yes, so area of a triangle, is equal to half into base into height. Clear? Area of a triangle is equal to half into base into height. Now area of a triangle ka formula is what? So area of a triangle they had given here 9 plus 4 root 3 is equal to half into base. Base is given what here? 8 minus 4 root 3. Okay, multiply by height. Now 8 minus 4 root 3, if you see properly, we have the 8 and we have the 4. Can we take the 2 outside? So 1 upon 2 into 2, open the bracket, 4 minus 2 root 3 and multiply by height. So this 2 and 2 get cancelled. So that means now we have 9 plus 4 root 3 is equal to 4 minus 2 root 3 into height, which is nothing but 9 plus 4 root 3 upon 4 minus 2 root 3 is equal to height. Simple. That means we have to find out the height, but this is nothing but a irrational number. So like the same type ka sum, so we have to simplify by using rationalize the denominator. So whatever is given in the denominator, we multiply and divide the conjugate of the denominator. So let's do here. Okay, so okay, so height is equal to, so height is equal to 9 plus 4 root 3 upon 4 minus 2 root 3. Okay, so we'll multiply and divide the conjugate of the denominator, which is 4 plus 2 root 3 upon 4 plus 2 root 3. So that become 9, open the bracket, 4 plus 2 root 3 plus 4 root 3 multiply by 4 plus 2 root 3 upon 4 minus 2 root 3 and 4 plus 2 root 3. So now 9 4s are 36 plus 9 2s are 18, 18 root 3 plus 4 4s are 16 root 3 plus 4 2s are 8 into root 3 will give you 3 upon 4 ka like a minus b, a plus b, it become 4 square minus 2 root 3 square. Okay, so now which is nothing but 36 plus 18 plus 16, directly you can add. So 18 plus 16 is what? 34 root 3, then plus 8 is 24 upon 4 ka square 16 minus 2 ka square 4 and root 3 ka square 3, 4 3 are 12. Clear? Now 36 plus 24, that give you 3 plus 2, 5 plus 1 6, 60 plus 34 root 3 upon 16 minus 12, that give you 4. Okay, this will be 34, 8 plus 6 14, 34. So let's take the 2 common, so or you can just do is equal to 60 upon 4 plus 34 root 3 upon 4. So 4 15 ja, and this you can cancel, 17 2 ja, 2 2 ja. So the answer is 15 plus 17 upon 2 root 3. Okay, which is in the form of a plus b root 3, where a is equal to 15 and b is equal to 17 upon 2. Okay, and 15 and 17 upon 2 both are rational number. So this many centimeter is the height of the triangle. Okay, so they can give the area of a triangle, they can give like the area of a rectangle, they can give the volume ka sum, means they can give the any of the mensuration ka, whatever the formulas you know, area and volume ka, surface area ka, they can combine in this also. Okay, so you have to substitute the formula, simplify, you will get the one term and you have to just simplify. So Surd mein the basic we have this much only, the simple addition, subtraction, multiplication, and instead of the division, this is called the rationalize the denominator. Then they can give the simplify, like simplify the sum. Okay, so all this we let's do 1 2 more sum in this, and then we'll go to the next chapter. Okay, next one is 2 plus a root 5 into 7 minus 2 root 5 is equal to minus 16 plus b root 5. Okay, so you can see this side we have the two brackets. So first we'll simplify that. So that will be 2, open the bracket, 7 minus 2 root 5, then plus a root 5 multiply by 7 minus 2 root 5. That becomes 7 2 ja 14 minus 4 root 5 plus 7a root 5 minus 2a root 5 into root 5, that give you into 5. Okay, and this part you can keep as it is only, minus 16 plus b root 5. This also minus 16 plus b root 5. Okay, so now this side here we have 14 and this become minus 10a. So 14 minus 10a, and this is nothing but root 5 and root 5. So this become plus minus 4 plus 7a into root 5 is equal to, we have minus 16 plus b root 5. Okay, now once you get till here, now you have to equate both the side. Okay, the a part equate with the first one and the second part equate with the second part, because here this is the real part, like you can say this is the rational number, this is also rational number, and this has irrational number, and this also irrational number. So equating rational number with rational number, so 14 minus 10a is equal to minus 16. Clear? And irrational number, which is minus 4 plus 7a, is equal to b, because root 5 and root 5 get cancelled. So now 14 plus 16, 14 plus 16 is equal to 10a. 14 plus 16 is equal to 10a. 14 plus 16, that give you 30. So 30 is equal to 10a. So a is equal to 3. Okay, a is equal to 3. 30 divided by 10, a is equal to 3. Same way, now once you get a ka value 3 here, minus 4 plus 7a is equal to b. We have the equation minus 4 plus 7 into 3 is equal to b. So 21. So minus 4 plus 21 is equal to b. So therefore b is equal to 21 minus 4, that give you 17. So b is equal to 17. So a is equal to 3 and b is equal to 17. A is equal to 3, b is equal to 17. Clear? Okay, next one is square root of 6 minus x is equal to 3. Square root of 6 minus x is equal to 3. So what you have to do here, first we'll do squaring both the side. Okay, so root of 6 minus x the whole square is equal to 3 square. Okay, you remember we did one formula here, square root of a the whole square is equal to a. So you can say this get cancelled, so remaining is 6 minus x is equal to 9. Simple it is. Okay, so now 6 minus 9 is equal to x. So minus 3 is equal to x. So x is equal to minus 3. Next one, square root of 2x minus 4 minus 2 root of x minus 3 equal to 0. Okay, if you do squaring both the side, it becomes difficult because we have the a term is irrational number, b term also irrational number. Okay, so what we'll do here, we'll take the second part the other side. So what we'll do here, root of 2x minus 4 is equal to 2 square root of x minus 3. Okay, now we'll do the squaring both the side. What? Squaring both side now. Okay, so now this become 2x minus 4. So actually root and the square here get cancelled, right? So now this and the square get cancelled, become 2x minus 4 is equal to 2 ka square 4, and the root and the square get cancelled, become x minus 3. Okay, once we do the squaring both the side, it become more simple. So now this is 2x minus 4 is equal to 4x minus 12. So now minus 4 plus 12 is equal to 4x minus 2x. So 8 is equal to 2x. So 8 upon 2 is equal to x. So x is equal to 4 is the answer of this. Okay, and this type ka sum, if you get this type ka sum after solving the sum, you can substitute the value here and check the answer. If we substitute x ka value minus 3, so 6 minus minus 3, that become 9, and root 9 ka value is 3. Same way you have the 4 here, so 4 to the 8, 8 minus 4, that give you 4. Root 4 is nothing but the 2, and this will be 4 minus 3 is 1, root 1 is 1, so minus 2 into 1 is minus 2, so 2 minus 2, the answer is 0. So this way you can check the answer also. Okay, हाय बच्चों, आज हम पढ़ेंगे एक्सपोनेंट. ओके, उसे हम और इंडाइसेस भी कहते हैं, पावर एंड रूट्स भी कहते हैं. तो आज के चैप्टर में हम इसके बारे में डिटेल्स में पढ़ाई करेंगे. ओके, विल गोइंग टू स्टार्ट द एक्सपोनेंट, पावर एंड रूट्स, दैट आल्सो कॉल्ड द इंडाइसेस. ओके, सो व्हाट इज इंडाइसेस, व्हाट इज exponent, or where we use the exponent, where we use the power. Okay, so if I say to write 2 5 times, okay, so what we'll do here, 2 into 2 into 2 into 2 into 2. So this will be what? 2 5 times. Okay, 1 2 3 4 5 times. So 2 5 times. Okay, so we can write down the 5 times. If I say write down 5 10 times. Okay, so what we'll do here, 1 2 3 4 5 6 7 8 9 10. Okay, 1 2 3 4 5 6 7 8 9 10 times. So this is 5 10 times. Okay, now if I say multiply 2 5 times with 2 7 times, so again what you will do here, again you will be multiplying 2 7 times. So right here, then you will add everything, you will get the answer. But if I will say multiply, so 2 into 2 4, 4 into 2 8, 8 into 2 16 into 32, then again we have the 7 more times here, then we'll multiply, that become a longer process. So instead of that, we'll come to know the formula or the exponent or the power or the indices. Okay, we'll use that to get the answer. Okay, so suppose we have something 2 raised to 5. How to read this? 2 raised to 5 or 2 to the power 5. 2 is the base. Okay, this 2 is known as the base. This 2 is known as the base, and this is known as the power or exponent. Okay, this 2 is known as the base and 5 is known as the power or the exponent. So instead of writing the whole multiplication, we'll simply write 2 how many times, 2 how many times, though kitni bar, like here 2 5 times. Okay, so instead of writing 2 into 2 into 2 into 2 into 2, we'll simply write 2 raised to 5. Okay, 2 raised to 5. This is 1 2 3 4 5 6 7 8 9 10. So this we can write down 5 raised to 10. Clear? So big part, big multiplication, okay, we can write down in the short form में. Now what will happen once we write in the small part में, short form में, in the exponent power form में, then we can multiply in this, we can add also in this, we can subtract also in this. So okay, we can do different multiplication, different calculation we can do in this. Okay, so once we get this formula, okay, so the first thing, this we read at 2 raised to 5 or 2 to the power 5, where 2 is the base and 5 is the power or the exponent. Okay, so this is always on the top of this, like a raised to m, a raised to m, a to the power m. Okay, so now here we have few formulas. Okay, so the formula, once you know the formula, you can easily solve the sum. And in indices chapter mein this formula is very important, and once if you know the properly the exponent, then you can easily solve the log also, because the log is nothing but they are just reciprocal, you can say, or they are correlated to each other, exponent and log. So suppose we have the first formula, a raised to m multiplied by a raised to n. Okay, then a raised to m divided by a raised to n. Okay, so multiplication का one rule we have, then division का one rule we have, then we have a raised to m raised to n, then we have a raised to 0 का one formula. Okay, then we have a raised to minus m का one formula, then we have a into b raised to 1 का formula, a into b whole thing raised to m का formula we have, then we have a upon b raised to m का formula we have. Okay, then in this only, so actually this is the 1 2 3 4 5 6 7 is the main formula. In this only, okay, we have to know what is the meaning of root a, what is the meaning of cube root of a. Okay, what is the meaning of 1 upon square root of a, 1 upon cube root of a. Okay, then 1 upon nth root of a. Okay, then nth root of a also without denominator, a also. Then you can write down here one more, that is nth root of a raised to m. This actually come in the surd part mein. Okay, this is actually formula for the surd, S-U-R-D-S, surds. Okay, so here the main formula is the other formulas, and if you know this formula, this is important for the exponent chapter itself as well as the log also. Okay, so the first formula we have a raised to m into a raised to m. So the important part, if you see properly here, both the bases are same, both the base is same. So whenever the base is same, whenever base is same, this is also a, this also a, so and it given multiplication, so it become a raised to m plus n. Okay, what is the rule? Whenever both the base are same and is given multiplication, so we'll add the power. Okay, whenever it is both the base are same and is given multiplication, so we have to add the power. Same way, whenever both the base are same and division given, so we'll subtract the power. Clear? A raised to m plus n, then if it is division given, so a raised to m minus n. Same way, if it is given a raised to m raised to n, okay, means power given, power ka power they had given, so we'll multiply both the power, we'll multiply both the power. A raised to m raised to n given, so it become a raised to m multiplied by n. Then anything raised to 0 is 1, anything raised to 0 is 1, but the very important part, a is not equal to 0, a is not equal to 0. A raised to 0 is 1. But when A will be any positive number or any negative number, but A cannot be 0. A cannot be 0. So A is any positive number or negative number. So anything raised to 0 is 1. Sometimes they ask true or false. So it is false. Okay, A raised to 0 is 1. It is not always 1. It is only for positive number and negative number. So if they ask you A raised to 0 is equal to 1 always, no, it is not always. A is not equal to 0, then only it will be 1 unless it is not defined. Okay, then anything raised to negative number, it will be 1 upon A raised to positive number. That is 1 upon A raised to. Okay, so A raised to minus m is equal to 1 upon A raised to m. So means whatever raised to negative number given, so if you do reciprocal, it will become 1 upon A raised to m. Okay, the next one is when the base is not same but the power is only 1 given. So we can separate this A raised to m, then multiply by B raised to m. Okay, here one more very important thing. This is given multiplication. Okay, A plus B raised to m is not equal to A raised to m plus B raised to m. Okay, this is not equal to. Understood? This is not equal to, because we use the formula na, A plus B whole square is not A square plus B square, it is A square plus 2AB plus B square. So this rule is applicable for multiplication and division, not for addition and subtraction. Okay, so A into B raised to m is A raised to m into B raised to m, and A upon B raised to m is equal to A raised to m upon B raised to m. Clear? So these are the main 7 formula which you have to by heart to get the answer, and afterward once you get the log chapter, so log is also based on the indices rule only. Okay, so whatever rule we have here, these are the very important rule for the school syllabus as well as for the future. If you want to study the log, we will use again this. Okay, and the next part is the what is the value. Okay, if they ask you write root A in the power form. Okay, so root is nothing but A raised to half. Okay, square root or under root of anything is nothing but A raised to half. Same way cube root of A is equal to A raised to 1 upon 3, and if it is given in the denominator square root, so actually it become 1 upon A raised to half. Okay, then by using this formula, if we write in the numerator, so become A raised to minus half. Okay, so whatever given root of A, that become A raised to half, but if it is given in the denominator, so that become A raised to minus half. Same way 1 upon cube root of A is nothing but A raised to minus 1 upon 3. Then same way 1 upon nth root of A is nothing but A raised to minus 1 upon n. Okay, and nth root of A is nothing but A raised to 1 upon n, and this will be actually A raised to m and then raised to 1 upon n, so it become total combined become A raised to m upon n. Okay, so A raised to m into A raised to n is A raised to m plus n. A raised to m divided by A raised to n is equal to A raised to m minus n. A raised to m raised to n is equal to A raised to m into n. A raised to 0 is equal to 1, where A is not equal to 0. A raised to minus m is equal to 1 upon A raised to m. Then A into B raised to m is equal to A raised to m into B raised to m. Then A upon B raised to m is equal to A raised to m upon B raised to m. And then square root of A is equal to A raised to half. Cube root of A is equal to A raised to 1 upon 3. 1 upon square root of A is equal to A raised to minus half. 1 upon cube root of a is equal to a raised to minus 1 upon 3. Then 1 upon nth root of a is equal to a raised to minus 1 upon n, and if it is only nth root of a given, so a raised to 1 upon n, and nth root of a raised to m is nothing but a raised to m upon n. Okay, so now what we'll do here, we'll take the 1 part. Okay, before that, the one small sum they can ask you like this type of sum, write down 2 5 times in the exponent form. So 2 5 times will be 2 into 2 into 2 into 2 into 2, and then 5 times in the exponent form will be 2 raised to 5. So this type of sum also they can ask in the paper. Okay, like write down 5 10 times in the exponent form. So 5 raised to 10. So whatever number they given and they ask anything raised to that or that many times, so we write here that raised to whatever times they ask you. Okay, so that can be a normal number, that can be a fraction also, like we have 1 upon 2 into minus 1 upon 2 into minus 1 upon 2 into minus 1 upon 2. So that you can simply write down minus 1 upon 2 whole thing raised to 3. Okay, instead of multiplying that, and then minus 1 ka cube is equal to minus 1 and 2 ka cube is equal to 8. So instead of doing all this, we can simplify directly after writing in the exponent form also. Okay, so now we'll do 1 formula ka, we'll do few sums. Okay, so let's do the examples. Like the first one is evaluate 3 upon 7 raised to 3. So okay, this type of sum they can ask. So what we have to do here, 3 upon 7 raised to 3 given, meaning it will be 3 times into 3 upon 7 into 3 upon 7, and then we have to multiply 3 into 3 9 into 3 27, and then 7 into 7 49, 49 3 ja 343, 340 proper it is na, 49 into 7 63 6 9 28 34, yes, it will be right. So 343. Actually we can find out the 3 ka cube and 7 ka cube also. So the answer is 27 upon 343. Okay, same way the second one, minus 5 upon 6 raised to 4. So see, one thing you can just write down minus 5 upon 4 minus 5 upon 6 into minus 5 upon 6 into minus 5 upon 6 into minus 5 upon 6. Okay, then you will multiply minus 5 into minus 5, the answer into minus 5, then again that answer into minus 5. But instead of doing that, what you can do here, any, okay, actually in the formula also you can write down the one more formula here, minus 1 raised to, okay, first 1 raised to any number is equal to 1. Okay, 1 raised to any number is equal to 1, and minus 1 raised to odd number is equal to minus 1, and minus 1 raised to even number is equal to plus 1. Okay, so actually this is not the formula, this is the basic concept it is. So 1 raised to any number given, it will be 1, and minus 1 raised to any odd number given, then the answer will be minus 1, and minus 1 raised to any even number given, then it will be plus 1. Okay, so we'll apply the same rule here also. Now we'll take only minus, or you can say minus 1 raised to 4. So minus raised to 4 minus raised to even number, the answer is plus. Okay, minus, so no need to multiply minus into minus into minus into minus. Okay, directly you can say, or you can see also minus into minus become plus, plus into minus is minus, and minus into minus become the plus. So the answer is plus, but instead of doing that, you just count how many times it is given. So minus given raised to 4 means 4 times given, which is even number, so the answer will be plus. If it is odd number, the answer will be minus. Clear? And then next will be 5 into 5, 25, 25 into 5, 125, into 5 is 625, or you can say 5 into 5, 25, 5 into 5, 25, so 25 into 25, that gives you 625. So this will be 5 raised to 4 is 625. Next one is 6 into 6 into 6 into 6, that will be 6 raised to 4. You can say 6 into 6, 36, 6 into 6, 36, then 36 into 36, 1296, or you can multiply also and you get the answer. So the answer is 125 over 1296. Okay, so that different ways are there. You can multiply 6 into 6, 36, 36 into 6, that give you 216, 216 into 6, that give you 1296, or you can multiply 36 into 36, that is nothing but 36 ka square, and this square ka rule already we did in the previous lecture mein. Okay, 6 ka square, so we have to do in the 3 parts mein, 1, 2 and 3. So the first part is 6 ka square, 36, then multiply both the number and double it. So 3 6 ja 18, 18 2 ja 36, and then 3 ka square 9. So write the ones place number here, then 3 comes here, 36 plus 3 become 39, so 9 here, 3 comes here, 9 plus 3 12, so 1296. Okay, so you can do by that way also, you will get the answer. Next one is minus 3 upon 4 raised to 5. Okay, so now again negative number raised to 5 given. Okay, minus 3 upon 4 into 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 minus 3 upon 4. Okay, so just count how many times given, raised to 5, which is odd number, or 1 2 3 4 5, which is odd number. So the answer will be minus. Answer is minus. 3 3 ja 9, 9 3 ja 27, 27 3 ja 81, 81 3 ja 243. So the numerator is 243. Okay, then next one is 4 into 4, 16, 16 4 ja 64, 64 4 ja 256, 256 into 4, 1056. Okay, you can multiply also 16, 16 and then multiply 4, 16 ka square 256, 256 into 4, 6 4 ja 24, carry 2, 20 plus 2 20. Okay, then 5 2 ja 4 2 ja 8 plus 2 10, 1024, 1024. So 4 into 4, 16, 16 into 4, 64 into 4, 64 into 4, that give you 256, 256 into 4, that give you 1024. So minus 243 into minus 243 upon 1024. So this will be the answer of the third one. Okay, let's do few more sums. Okay, so next part is expressed in exponential form. Yes, like last we did, the last part we did, they had given the exponential form and they asked the simplify, evaluate. Okay, here they given the simplified form and we want the exponential form. Exponential form meaning something raised to, like a upon b raised to m form में. Okay, so what we have to do here, we have to think a number. Okay, something raised to like any number raised to give you 256 and something raised to the same number give you 625. Okay, so what we can do here, now this is ending with 5 given, so I can directly say this will be what, 5 raised to 4. Okay, 625 is nothing but 5 raised to 4. So 256 also we have to write something raised to 4 only. So you can do here 256, you can divide by 4, 4, 6 ja 24, 1, 4 4 ja, then again 4, 16 ja 4, 4 ja 4, 1 ja. So that become here 4 raised to 4. Now here the question come, so why you took the only 4 raised to 4? You can cancel by 2 also, you can get the answer 256. Okay, it goes in 2 also, 1 ja, 2 ja, 8 ja, then again 2 ja, this 64, again 2 ja, 32, again 2 ja, 16, 2 ja, 8, 2 ja, 4, 2 ja, 2, 2 ja, 1. So this will be 1, 2, 3, 4, 5, 6, 7, 8. So this we can also write down 2 raised to 8. Okay. Now what I told here, express in exponential form. So you have to write down in the form of a upon b raised to m. So if you see properly, a upon b raised to m is nothing but this m will be common for the numerator as well as for denominator. So that's why, see, the 2 raised to 8 also give you 256, but we want the power 4. So power 4 meaning the base has to be the 4. So the answer is 4 upon 5 whole thing raised to 4. Okay, so the answer is 4 upon 5 raised to 4, not 2 raised to 8 upon 5 raised to 4. Okay, so that will be the two separate part come, but actual answer will be 4 upon 5 raised to 4. Okay, same way minus 1 upon 512. So first 512 we have to find the factor. 512 will be what? 512. Okay, actually if you see this same sum here, if at here 512 and then again cancel by 2, so you will get the factor of this directly. Okay, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is nothing but 2 raised to 9. Now the numerator, that you can again write down minus 1 raised to 9, because what is minus 1 raised to 9? That give you minus 1. So the answer for this will be minus 1 upon 2 whole thing raised to 9. Okay, minus 1 upon 2 whole thing raised to 9. Next one is minus 32 and then 3125. Okay, again ending with 5, so that will be something raised to 5 only. Okay, so 625 we have raised to 4. If you multiply 625 into 5, okay, into 5, so 5 has a 25, carry 2, 5 has a 10 to 12, carry 2, 6, 30, 31. So 3125. So yes, that will be 5 raised to 5, 5 raised to 5, 5 raised to 5, and this 32 is 2 raised to 5. So minus 2 upon 5 whole thing raised to 5. Okay, whole thing raised to 5, not 3, it is 5. So if you see properly, like if your multiplication, you're squaring the number, okay, if it is good, then you can easily solve these sums unless you take some times. Like I know 625 is 5 raised to 4 and I just multiply with the 5, so I got 3125. That means this is 5 raised to 5. Then this was like we did 256 raised to 4 give you 4 raised to 4 give you 256, or 2 raised to 8 give you 256, and we had 512, which is just double of this. So if this is 8, so that will be 9. So minus 1 upon 2 raised to 9. So 2 raised to 9 give you 512. So again, this will be totally depend on the calculation. If your calculation is good, you can easily solve, unless it will take some time. But if you do practice, you can easily solve the sum. Okay, let's do the next part. Okay, let's do few more sums based on the formula whatever we did. Okay, so when the base are same and its multiplication given, so we have to add the power. So that become here, both base is given 4, so 4 raised to 3 plus 5, that become 8. So 4 raised to 8. The next one is, now this is division given, again both the base are same, and so we have to subtract the power. So 7 raised to 6 minus 3, that give you 3. Okay, third one is 11 raised to 3 upon 11 raised to 7, so that give you 11 raised to 3 minus 7, that give you 11 raised to minus 4. So either you write the answer 11 raised to minus 4, or sometimes they ask the write the answer in the positive exponent, so then the answer will be 1 upon 11 raised to 4. Okay, 1 over 11 raised to 4. Then next one is minus 5 raised to 4 raised to 2. So whenever 2 raised to given, you have to multiply. So minus 5 raised to 4 to the 8. Okay, now this is given 5 into 4 raised to 2, so that become 5 raised to 2 into 4 raised to 2. Okay, so write in the simplified form. So you can go further of this. So 5 chi square 25 and 4 chi square, that give you 16. 25 into 16, that give you 400. Okay, and if you do here also 5 into 4 20, 20 chi square give you 400. You can do that also. And then next one is anything raised to 0, that give you 1. Okay, this is non-zero number, so anything raised to 0 give you 1. Okay, now this 4 raised to 8, no need to further simplify. 7 raised to 3, if you want, you can simplify further. Okay, because asking to solve here, so you can get the answer 7 raised to 3. You can write down answer 343. Okay, then you can simplify this also further. This is like minus 5 raised to 8 as a big number comes, so you can leave as it is. Another to same only it is. Okay, so these are the way to solve. Okay, if you see here, we have to just know the formula in this, and once you know the formula, you can easily solve. And there's for 1 marks, 2 marks sum based on this. Okay, so only formula if you know, you can easily solve this. Okay, let's do a few more challenging sum. Okay, so like the first one is 4 raised to 2 minus n multiplied by 2 raised to n plus 1 whole thing upon square root of 2 raised to n. Okay, so now if you see the sum, it looks very difficult, but if you go to solve this, it becomes very simple. You have to just follow some basic rule. Okay, first of all, make all the base 2. First make all the base 2. So this will be 2 raised to 2 whole thing raised to 2 minus n multiplied by 2 raised to n plus 1 whole thing upon 2 raised to n raised to half. Okay, step by step, because the square root is nothing but raised to half. So this become 2 raised to 2 to the 4 minus 2n multiplied by 2 raised to n plus 1 whole thing upon 2 raised to n upon 2. Okay, then again it become 2 raised to 4 minus 2n plus n plus 1, directly here only minus n upon 2, because the multiplication you have to add the power and division you have to subtract the power. So directly in one step may be solved here. Then 2 raised to now 1 minus 2 minus 1 minus 1 minus half, so become minus 3 upon 2n and 4 plus 1, that give you 5. So the answer is 2 raised to minus 3 upon 2n plus 5 is the answer. Proper. 4 plus 1 5, and then this will be minus 2 plus 1 give you minus 1 minus 1 minus half minus 3 upon 2n. So 2 raised to minus 3 upon 2n plus 5 is the answer. Okay, let's do one more sum. Okay, the next one is 81 raised to x plus 1 plus 3 into 9 raised to 2x upon 3 raised to x minus 2 into 27 raised to x plus 1. Okay, now if you see again in this, the base we can take all the base as 3. Okay, take all the base as 3. So now 81 is nothing but 3 raised to 4 and raised to x plus 1, then plus 3 keep as it is, and this will be 3 raised to 2 raised to 2x whole thing upon, this is 3 raised to x minus 2 as it is into 3 raised to 3 and x plus 1 as it is. So that become 3 raised to 4x plus 4 plus 3 into 3 raised to 4x. Okay, upon both the base are same, so 3 raised to x minus 2 plus 3x plus 3 1 ja 3, step by step. Okay, next part will be 3 raised to 4x plus 4 plus 3 raised to 4x plus 1, because this will be raised to 1 given. Okay, now upon 3 raised to x plus 3x become 4x, and this will be 3 minus 1, that give you 3 minus 2, that give you plus 1. Okay, now we can't cancel this and this because there is a plus sign given in between. So what we'll do here further in this, what is common in both? So this is nothing but 3 raised to 4 x into 3 raised to 4 plus 3 raised to 4x into 3 raised to 1 upon 3 raised to 4x into 3 raised to 1. 4x it is, this is 4x. Okay, now what is common in the numerator? So we can take 3 raised to 4x common, and then we have 3 raised to 4 and into 3 raised to 1, so that become 3 raised to 1 is common, so remaining is 3 raised to 3, and this become only 1 because everything is outside, upon 3 raised to 4x into 3 raised to 1. Okay, this is x. So 3 raised to 4x get cancelled and 3 raised to 1 also get cancelled. So 3 raised to 3, that give you 27 plus 1, that give you 27 plus 1, 28. So the final answer is 28 is the answer. Okay, so here it looks like difficult, but if you go step by step now, it will be very simple. Okay, so this is the way we have to solve the exponent, and the exponent we can use in the the real life word problem also. Okay, so suppose if something is given, then any number is given, like the 2 raised to 9 is the number, or suppose suppose they given 45 kilometer, convert into millimeter. Okay, convert into millimeter and write the answer in the exponential form. So first of all, kilometer to millimeter, kilometer to millimeter. So we have King Henry died, mother didn't cry much. So 1 2 3 4 5 6, so directly 45 into 10 raised to 6, that will be 4.5 into 10 raised to 7 millimeter is the answer. Okay, so the other sum you can do in word problem also, in the real life situation also. Okay, so that will do later part mein. As of now we will stop here. Okay, so the main thing here, you can just by heart all the formulas, so you can easily solve the sum. It's a simple chapter, but only based on the formula. If you don't know the formula, you cannot solve the sum. हेलो बच्चों, ऑलरेडी हमने सर्ड और इंडाइसेस कवर कर लिया है. अभी द नेक्स्ट पार्ट हमको लॉगरिथम के बारे में पढ़ना है. ओके, सो लॉगरिथम अगर आप देखेंगे तो it is just very similar to the indices. That's why again we are revising the indices, all the formulas. Okay, once we know all the indices का formula, so we can directly solve the logarithm also. We'll discuss all the formula also. So like the first thing, okay, first thing we have a raised to x is equal to b. This is what in the indices form, or you can say exponent form. A raised to x is equal to b, where a is the base. Okay, this is called the base, this is the power, and this will be the answer. Okay, this is the answer. Okay, so any exponent, any exponential function given, or any indices given, so it has the three part. Okay, it has the mainly three part: the base, then the power of that, and then the answer of this. Means the base raised to power, you will get the answer. Now if you have indices form, we can convert into logarithmic form. Okay, so when we convert into the log form, log, okay, when we convert to the log form, so the base will be as it is, the base is as it is, a only. Whatever the answer given, that become the power, and whatever the power given, that become the answer. Okay, so what is the rule here? Base will be as it is, answer become the power, and power become the answer. Clear? Whatever is given here, the exponent form may given a raised to x is equal to b. So a is the base. In this also you will get the base a only. Whatever the answer here, that become the power, and whatever the power, that become the answer. Okay. Acha. Now this we read at log b to the base a is equal to x. Now the question is, why we use the log? Okay, why we use the log? What is where we will use the log? Okay. So first thing, it is there the part of the syllabus, so we have to do. Okay, and why we are doing this? What is the use in the future? So log is mainly for complex calculation. Log is mainly we use for complex calculation. Like in our time when we used to study, that time we don't have the graphic calculator, scientific calculator. That time we used to do everything with the help of the log book. Okay, we used to get a log book in the exam also. We used to see the logarithm part in that with the mantissa, characteristics and everything. So we can use, like suppose we have to find out cube like the square root of 32579 into 10 raised to 7 upon 0.389238 into 10 raised to minus 7. So like this all calculation. Okay, now this we cannot do directly on a piece of paper without help of the calculator, but in our time we didn't have the calculator also, so we used to solve this by using the log book. Okay, with the help of the log book. So logarithm chapter is nothing but, or the log we used to find the complex calculation. Okay, with the help of the log book we can find out the complex calculation. Clear? So log is mainly used for that only. Okay, to find the complex calculation. Log में will get the two parts में. Okay, the first part will be log with the base. Okay, like suppose log with the base, the one will be the 10. Okay, log with the base 10, that we also call the LG. Okay, only LG. LGB meaning the log with the base 10, log b to the base 10. So LG, if there is no base given, is understood it is the 10. Okay, and the next one, the log b to the base e, that is called the ln b. Okay, if the base as e is like the natural log. Okay, we will studying in the part में the main details में what is the ln b or log with the base e. Okay, log with the base e or ln e is called the natural logarithm, and this you can simply call it as common logarithm. Okay, because here the base will be 10 or any other base also is possible here. Okay, like the log 5 to the base 2. So this is also a log only. So these are the common log. This is called the common log, and this is called the natural log. Okay, natural log. Okay, so all this will be studying in details में. Okay, so the first thing, the conversion from the exponential to log or log to exponential. So you can write on the formula if you want. If it is a raised to x is equal to b given, then we can convert into logarithmic form. Log b to the base a is equal to x, or log b to the base a x given, then if you convert in the exponential form, it become a raised to x is equal to b. Clear? So it is vice versa. You can convert from the exponential to log or log to exponential. So both the way we can find out the okay. Sometimes they ask in the paper conversion, they can ask in the MCQ also. Okay, now the formula. Okay, now as I told here, the formula are what? Very similar it is. Okay, whenever it's multiplication, indices में you have to add the power. Whenever it's a multiplication in indices में we have to add the power. Here if it is log A plus log B given, then it become what? Acha. Now whenever I'm not writing anything over here, the base, it means they are 10 or there has to be the same base. Okay, either they will give the base, then both the base has to be the same. Okay, unless without the base, without base means the base will be the 10. Okay, so we can say here the base is m, this base also m. So log A to the base m plus log B to the base m, so that become here log AB to the base m. Okay, see what is the similarity here? If it is multiplication, we have to add the power. Here if there is a 2 log, addition of the 2 log given with the same base, so we can multiply the power. Okay, here also if the base are same, then only we can add. Here also if the base are same, then only we can multiply. Like the addition is nothing but you have to multiply both the log. Okay, similarly if we have log A to the base m minus log B to the base m, then it become log AB. Okay, is minus means division, so A upon B to the base m. Okay, so if it is addition given, we have to multiply both the power. If it is division given, subtraction given, so we divide both the we divide the first one upon the second one. We divide the A upon B, we write the answer. Okay, next one is, now suppose we have log, okay, log A raised to m given. Okay, whatever the base given here. So now what is the answer? So like see here, if we have the anything raised to and again raised, so this is what that will come before. This become the m log A to the base n. Okay, so anything raised to given, that we get before the log. Okay, next one is similarly, like suppose here given log A raised to minus m, so that become minus you can say, okay, suppose this is the again n is here, so it is minus m log A. Okay, or you can say minus will nothing but it will go in the denominator also. Okay, so this you can also write down is equal to m upon log A also, because A raised to, so actually this is nothing but, see, log A raised to minus 1 is nothing but log 1 upon A. Okay, log 1 upon A. Log A raised to minus m, so either you write down here minus m log A, or it is nothing but m log 1 upon A. M log 1 upon A, because minus m is nothing but, okay, so m you take this side, so A raised to minus 1, A raised to minus 1 is nothing but 1 upon A. Clear? Next one is anything raised to 0 is equal to 1 where A is not equal to 0. So in log form में, okay, in log form में log A to the base A is equal to 1. Log A to the base A is equal to 1 where A greater than 0. Okay, A cannot be negative number or a cannot be 0. Clear? Okay, so these are the main formula. Acha, here one more thing, like they given here. So here if it is given log a the whole square, okay, and log a square, they both are not same. Okay, this meaning we can take this whole thing ka square, and this is nothing but 2 log a. This is like the log a into log a, but this is nothing but log a plus log a. Okay, clear? Everything, other basic rules are there. Then next they can give the sum. Okay, one will be the change the base rule. If it is like the given log a to the base b, this is very important rule. This is called the change the base rule. So if you want to change the base and the power, if you want to change the base and power, so that will be 1 upon log b to the base a. 1 upon log b to the base a means if you want to change the base from the b to a, now the base is given here b, if you want to change to a, so it become 1 upon log b to the base a. Or if you want separate change, like you directly want some other base, so we can write on here log a upon log b, and whatever the base you want you can write down, but make sure both the base will be same. This is called the change the base rule. Okay, change the base rule. Then one formula is there, a raised to log b to the base a. This is also very important formula. So there are the two, like one is given the exponential form, the second is the log form, but both ka base is what? If both the base are same, so then the answer will be whatever the power given. Okay, a raised to log b to the base a is equal to b. Okay, and next one is with the when the base is 10, so log 1 to the base 10, then log 10 to the base 10, then log 100 to the base 10, log 1000 to the base 10. Okay, so this you can simply check the number of zeros, like log 1 to the base 10, so all base will be the 10. So what is the power here? 1, and 1 has how many 0? 0, 1. There is no 0 given, so it will be 0. Now log 10 to the base 10, 10 mein how many 0 given? 1, so 1 is the answer directly. Okay, 100 mein how many 0 given? 2, so 2 is the answer. 1000 mein 3, so 3 is the answer, meaning log 10 raised to 19 to the base 10, how many zeros given here? 19, so the answer will be 19. Okay, that's simple, but this is for when the base is 10, and the other formula will be what? Log a to the base a is 1, meaning suppose you have the log 5 to the base 5, when the base and the power both are same, so the answer is 1. Okay, and log may, if it is given here log b to the base a, so always remember this b always greater than 0. It can't be 0 also, it is always greater than 0. Okay, this part you require in when we have to sketch the graph of this. Okay, so we need the domain and the range, vertical asymptote, so that time you have to remember here this power is always greater than 0. It cannot be 0 or it cannot be negative number. Okay. So the other formula you have to by heart. So it is very similar to indices, that's why we combine. And the third also is like all this part only. Okay, so that's why it's a combination only come. So like most of the book may they given the combine only surd, indices and the logarithm, and like the sum also they ask. Okay, but afterward they can combine also with other chapter. This will very important in the differentiation also. Trigonometry may also very important. Calculus may it is very important. Okay, so indices already we did, surd we already did, logarithm, all the formula. So I explain everything, all the formula here. Now we'll do the sum based on this. Okay, again go through all the formulas here. Even you can take the screenshot also of this. Okay, these are the indices ka formula, and then this one is all the log ka formula. So starting from the beginning, if it is given a raised to x is equal to b, so we can convert into the log form. So log will be log, the base will be the same only, log b to the base a is equal to x. Okay, and then all the formula like the log a to the base m plus log b to the base m is equal to log a b to the base m, then log a to the base m minus log b to the base m. So plus given, multiplication, like here opposite way, here multiplication given we have to add, here plus given will multiply, here division given will subtract, here subtraction given, so we can divide. Same way if it is raised to power given, so here we can multiply, here we can take ahead. Okay, raised to negative number, so 1 upon, the same thing it come here, a raised to 0 is 1, here log a to the base a is equal to 1. Okay, and like these are the important thing. If it is given log a the whole square, it means log a into log a, but suppose they given the log a square, only a ka square given, it means we can take the 2 before this, that becomes the 2 log a, which is nothing but log a plus log a. Okay, and then this log a to the base a is 1, so same way like log 5 to the base 5 is equal to 1. Okay, next one is, now this is again, these two are very important formula, log a to the base b. Okay, now when we use this formula, okay, we'll solve the sum based on this. But see here, if you don't want the base b, suppose you want the base a or you want some other base, so you can change. If you want the base a, so you can write a reciprocal of that, means 1 upon log b to the base a. Same way, if suppose you don't want the base a also, you don't want the base b also, so you can make it log a upon log b with whatever base you want, but only make sure both the base has to be the same. Next one is a raised to log b to the base a is equal to b. So let's see the formula here. This is what exponential form, this is logarithmic form. So this base and this base, if both are same, if both the base are same, then whatever the power given here, log ka whatever power given, that will be your answer. And suppose it is log given, so log 1 0, log 10 1, log 100 2, log 1000 3, log of 10 raised to whatever number given, that will be your answer. Okay, now this is all about the common logarithm. Now the same way we have the natural logarithm. Okay, so whatever formula we did here, that all formula is applicable in the natural logarithm also. Natural logarithm is nothing but the, like instead of the base 10 or any number, it will be the base is like here log a to the base e is nothing but the ln a. Okay, so ln a given, like how we have the lg. Okay, how like we have the lg a l. Okay, l like lg a is nothing but the log a to the base 10. So lg means understood the base is 10. Same way ln is understood the base is 10. Base is e. Okay, so ln e, if they ask you the value, okay, ln ka base is what? So it is e only, so the answer is 1. So that's why ln e is nothing but 1 is the answer. Okay, so natural logarithm is again the same as the normal log only, but this give the more accurate value. Okay, this give the more accurate, like more accurate value in the sense like whenever not for like our sum is like what, maximum 2 or 3 decimal place we have to find out. But whenever we have to find any complex calculation, like for the space agency and all that places, now whenever they need like the 30 to 40 decimal places, so that time they need more and more accurate value. So this give the natural logarithm give the more accurate value compared to the common logarithm. That's why they are taking the unit that like this is now more popular in terms of the log में. So log with the base e is called the ln e, that is same as the natural logarithm. Okay, so let's start the sum. Okay, now let's do the example. So the first one is the convert the following to logarithmic form. Okay, we did the formula. So if it is a raised to x is equal to b given, then log answer log b to the base a is equal to x, means the base will be as it is, whatever the answer given, that become the power, and power become the answer. So now here first we write the log. Okay, they can ask 1 mark, 2 mark sum. This is log. Now what is the answer given? 16. So the answer is 16. What is the base given? 4. What is the power given? That become the answer. Simple. Log 16 to the base 4 is equal to 2. Next one, log answer to the base 2 given is equal to power. Okay, just by looking you can get the answer. You have to just remember the rule. Log answer, which is 1000, with the base 10 is equal to power. Here what is the answer? So log, what is the answer given? Half. What is the base given? 2 is equal to -1. Clear? Okay, you have to just remember the rule, you can get the answer. Now convert the following to index form. That is also the same, vice versa. If it is given a raised to x equal to b, then log b to the base a is equal to x. If it is given log b to the base a is equal to x, then whatever the base as it is, whatever the answer given, that become the power, whatever the power given, that become the answer. The same thing. So here what is the base given? 2. What is the answer given? 3. What is the power given? 8. So 2 raised to 3 is equal to 8. In this one, what is the base given? 5. What is the answer given? 2 is equal to, what is the power given? 25. Okay, same way, what is the base given? 2. What is the answer given? Half is equal to √2. Clear? Simple it is. So you have to just remember the formula. A raised to x is equal to b, then log b to the base a is equal to x. Okay, let's do a few more sums. Okay, next one is solve the following logarithmic equation. So the sum is given, log x to the base 3 is equal to 2. So 3 raised to 2 is equal to x. So 3 raised to 2, which is 9. So x is equal to 9. Okay, simple, only based on the formula. Half raised to x is equal to 16. So 2 raised to minus x is equal to 2 raised to 4. So x is minus x is equal to 4. So x is equal to -4 is the answer. Clear? Next one is x raised to 2. Okay, the base raised to answer is equal to power. So x square is equal to 4x minus 3. So x square minus 4x plus 3 equal to 0. So x square minus 3x minus x plus 3 equal to 0. X open the bracket, x minus 3 minus 1 open the bracket, x minus 3 equal to 0. X minus 1 x minus 3 equal to 0. X is equal to 1 or x is equal to 3. Now once you get the more than one answer, you have to substitute and check the answer, it is right or no. So if we substitute x ka value 1, so 4 into 1, 4 minus 3. Okay, so that becomes the log 4 minus 3 is 1 to the base 1, and 1 to the base 1 is nothing but 1 only, but here they given the 2. So x is equal to 1 is not applicable. Okay, x is equal to 1 is not applicable. Next one is 3. So log 4 3 are 12, 12 minus 3 9 to the base 3 is equal to 2, 3 raised to 2 equal to 9. So yes, it is right. Okay, so x is equal to 3 is the answer. So sometimes you have to check the answer also. If we have more than one value, so we have to see sometimes both is possible, sometimes only one is the possible answer. Okay, next one is evaluate. Okay, so they had given the sum here, log to the base 5. Now this is what, log 6 to the base 6, log a to the base a. So 2 into 1 minus 3, log 3 to the base 3 is 1. So that become log to the base 5, 2 minus 1 is 1, and log 1 ka value is 0. So log 1 to the base 5 is nothing but 0, because the formula for log 1 to the base m is equal to 0. So log 1 of any base equal to 0. So log 1 to the base 5 equal to 0. Next one is, now this we have the log 2 root 2 to the base 2. So that become here log 2 raised to 1 and a half. So 1 plus half is equal to log to the base 2 given. So log 2 raised to 3 upon 2 to the base 2. So that become 3 upon 2 log 2 to the base 2 is nothing but 3 upon 2. So 3 upon 2 log 2 to the base 2 is nothing but 3 upon 2. Next one is, they given the log 8 to the base 2 and log 4 to the base 2, which is nothing but log 2 raised to 3 to the base a upon log 2 raised to 2 to the base a is nothing but 3 log 2 to the base 2 to the base a, okay, upon 2 log 2 to the base a. Now log 2 to the base a, log 2 to the base a is equal to 3 upon 2. Okay, so the answer is 3 upon 2. Okay, next one is log 3 to the base 6 plus log 2 to the base 6, which is nothing but log 3 into 2 to the base 6, which is log 6 to the base 6, which is nothing but 1. So log a to the base a is equal to 1. Okay, next one is, again we have the log with the base 2. So we can take the log with the base 2 outside. So we have 40 into 0.1 into 0.25. So 40 into 0.1 is 4, and 4 into 0.25, which is 4 into 1 upon 4, that give you 1. So that is nothing but log 1 to the base 2 is equal to 0. Log 1 of any base equal to 0 is the answer. Okay, now let's do few more complex sum. Okay, next one is simplify the following. The first one is given log 8 to the base 4 minus log 2 to the base 4. Okay, the base are same and they had given the minus in between. So that become the log 8 upon 2 to the base 4. Why? Log a to the base m minus log b to the base m is equal to log a upon b to the base m. So that is nothing but log 8 upon 4 give you 8 upon 2 give you 4, and with the base 4, so that become log 4 to the base 4, which is nothing but 1. Okay, next one is, now we have log x raised to 4 to the base 2 minus log x cube to the base 2. Again you can do the same thing, the base are same given. Okay, so that is nothing but x raised to 4 upon x cube, which is nothing but log, now this is what you can cancel, 4 minus is remaining is 1, so become x to the base 2. Okay, log x raised to 4 minus log x cube given to the base 2. So both the log with the base same given, so you have to divide the power. So x raised to 4 upon x raised to 3, that become x raised to 4 upon x raised to 3 x. So log x to the base 2. Next one is little different type का sum. Here they are given the log 2 to the base a का value 0.301 and log 3 to the base a का value they given 0.477. Now they are asking log 3 upon 4 to the base a का value. So first we'll simplify this. So this become log a upon b to the base a is nothing but log a to the base minus log b to the base a. Okay, so log 3 to the base a minus log 4 to the base a. So log 3 का value is what? 0.477 minus, now log 4 का value is not given, but they given the log 2 का value, which is nothing but 2 log 2 to the base a. How we got this? So this part is nothing but log 2 square to the base a, and that 2 will come here. So that is 2 log 2 to the base a, and that value is nothing but 0.301. So 0.477 minus 2, open the bracket, 0.301, which is nothing but 0.477 minus 3 to just 6, so 0.602 proper. And now 7 minus 2 give you 5, 7 minus 0 is 7, and 4 minus 6, okay, it is what? 4 minus 6, so it will be, no, then we have to take the bigger number first, so the answer will come here 0. So 2 minus 7, so 12 minus 7 is 5. Let's do here. So we have 0.602, and then we'll do here 0.477. Okay, 0. And then this is minus, this is plus given, so the answer become here minus, okay, and then 2, 12 minus 7 is 5, and this become here, cancel, this become 5, this become 10, 10 cancel become 9, 9 minus 7 is 2, okay, and 5 minus 4 is 1, 0. So the answer is minus 0.125, okay, minus 0.125, minus 0.125, okay. Okay, next one is log 2a to the base a upon log 3 to the base a, which is nothing but log 2a to the base a, and this will be what? Okay, this is not like the log a upon log b, so this is directly upon log 3 to the base a is nothing but log 2 to the base a into log a to the base a. So and log 2 to the base a का value we have, and upon log 3 to the base a, which is nothing but log 2 to the base a का value 0.301 into log a to the base a is nothing but 1. Wait, this is log ab, which is nothing but log a plus log b. Okay, so this is plus, and upon log 3 to the base a, that value is nothing but 0.477. So this is nothing but 1.301 upon 0.477. Okay, so then you have to divide this you have to multiply by 1000 upon multiply by 1000 is equal to 1301 upon 477, okay, which is equal to 2.7, okay, we have to divide. Okay, so if we divide 1301 upon 477, so we are getting 2.727. okay, so that you can do the division. Okay, you can do with the calculator also, if you calculator allowed in this, unless you can normal division you can do it. Okay, next one is given that LG means the log with the base 10 is equal to m, and LGY, that means the log with the base 10 is equal to n expressed. Now this we have to simplify first. So LG, okay, that is nothing but the log with the base 10, okay, then plus, okay, because this is multiplication, we have LG, that is again log root x upon y to the base 10, which is nothing but log 10 to the base 10 plus, now this is nothing but the half, so this is log x upon y raised to half, which is nothing but log 10 to the base 10 plus half log x upon y, nothing but the log x minus log y. Okay, so log 10 to the base 10 is nothing but the 1 plus half log x का value is nothing but the m minus log y का value is nothing but the n. So the answer is equal to 1 plus half m minus half n. Okay, 1 plus half m minus half n. Okay, the next one is express 3 plus log 5 to the base 2 as a single logarithm. Okay, means all simplify, make it the one log. Okay, so this we have 3 plus log 5 to the base 2. Okay, so now what we'll do here, we'll add in this also the log. Now what log will add in this? What is the base given? 2. So if we multiply 3 into log 2 to the base 2, what is log 2 to the base 2? 1. 1 into 3, same as 3 only, plus log 5 to the base 2. Clear? Which is nothing but log 2 raised to 3 is what? 8 to the base 2 plus log 5 to the base 2, which is nothing but log 8 into 5, 40 to the base 2. Okay, so log 40 to the base 2. So okay, next one is log 5 to the base 7 into log 9 to the base 5 into log 7 to the base 9. Okay, so we did the change the base rule. So log 7, log 5 to the base 7, nothing but log 5 upon log 7 into log 9 upon log 5 into log 7 upon log 9. Okay, so log 5 get cancelled, log 7 get cancelled, and log 9 get cancelled. So the answer is only 1. Okay, simple it is. Next one you take. So now we have here, so first thing log 2 to the base 3 as it is, plus log x plus 4 to the base 3 as it is equal to log x square to the base 3. Clear? Now what is log a plus log b? So that become log 2 open the bracket x plus 4 to the base 3 is equal to log x square to the base 3. So both the log with the base, so we can cancel this. So this become the 2x plus 8 is equal to x square. So x square minus 2x minus 8 equal to 0. Now we'll solve with the sum and product rule. So 4 2 is 8, 4 minus 2 is 2. So x square minus 4x plus 2x minus 8 equal to 0. So x minus 4 plus 2 x minus 4 equal to 0. So x plus 2 and x minus 4 equal to 0. So x is equal to minus 2 or x is equal to plus 4. Okay, now as I told before also, we have to check both the values. So x ka value we got minus 2 and x ka value we got 4. Now if we substitute here the x ka value minus 2, so we'll get here log minus 2 to the base 3, which is not applicable. That's why we cannot take the negative number. Okay, and if we get the 4 here, 4 plus 4 is possible and 4 is also possible. So x is equal to minus 2 is not applicable. So the final answer x is equal to 4 is the answer. Okay, so this compulsory, if you write both the values, they cut the marks for this. So always if you getting the more than one value, we have to substitute and verify the answer. Okay, next one is log x minus 1 to the base 2 plus log x minus 4 to the base 2 is equal to log 2x minus 6 to the base 2. So here log a plus log b is nothing but log x minus 1 into x minus 4 to the base 2, and this side we have the log 2x minus 6 to the base 2. we can cancel both the log and log because both the log ka base is same. Okay, then multiply both the bracket here. So this become x square minus 4x minus 1x become minus 5x, and 4 1 ja 4 is equal to 2x minus 6. So become x square minus 5 come here become minus 2 minus 7x, 4 plus 6 give you 10 equal to 0. So the two number will be minus 5 minus 2. So x square minus 5x minus 2x plus 10 equal to 0. So x minus 5 minus 2 x minus 5 equal to 0. So x minus 2 and x minus 5 equal to 0. So x is equal to 2 or x is equal to 5. Now both are plus here, but still we have to check the answer. If we substitute 2 ka value here, 2 minus 1, okay, possible. If we substitute 2 minus 4, what is 2 minus 4? That give you minus 2, and log of minus 2 is not possible. So x is equal to 2, not applicable. So x is equal to 5 is the answer of this. Okay, x is equal to 5 is the answer of the given sum. Next one is log x to the base 5 is equal to 4 log 5 to the base x. Okay, now here we have the 2 log, but one will be base 5. You can see here the power is x, base is 5. Here the power is 5, base is x. So what we'll do here, we'll use the formula, change the base. Change the base rule is what? 4 into 1 upon log x to the base 5 plus 3. Understood? What we did here, we did the formula in the beginning. Which formula? Log a to the base b is equal to 1 upon log b to the base a. Now what you can do here, let log x to the base 5 is equal to a. What we'll do here, let log x to the base 5 is equal to a. So we'll get a is equal to 4 upon a plus 3. Now take the LCM. So become a is equal to 4 plus 3a upon a. So that become a square is equal to 4 plus 3a. That become a square minus 3a minus 4 equal to 0. Now find out the two numbers whose addition is minus 3 and their multiplication is minus 4. So we'll get here a square minus 4a plus a minus 4 equal to 0. a minus 4 plus 1, a minus 4 equal to 0. a plus 1 and a minus 4 equal to 0. So a is equal to minus 1 or a is equal to 4. But this is not the answer. This is not the answer. Why? Because we have to get the x ka value. So what is a ka value we have? So that we have log x to the base 5 is equal to minus 1 or log x to the base 5 is equal to 4. Okay, so this side it becomes 5 raised to minus 1 is equal to x or 5 raised to 4 is equal to x. So 5 raised to minus 1 will be 1 upon 5. 1 upon 5 is equal to x, or this will be 5 raised to 4. 5 ka square 25, 25 ka square is 625. So x is equal to 625 is done. So x is equal to 1 upon 5 or x is equal to 625. Okay, and if you substitute 1 upon 5, so yes, we will get the answer here. Okay, next one is 6 raised to x plus 2 is equal to 21. Now how to solve this type ka sum? So what you have to do here, simply take the log on both the side. Okay, so taking log on both side. So we'll get here log 6 raised to x plus 2 is equal to log 21. So that become x plus 2 log 6 is equal to log 21. That become x log 6 plus 2 log 6 is equal to log 21. Okay, now the log part, you just keep the x part here, other everything you take the other side, become log 21 upon this become 2 will go there, become log 6 raised to 2 become 36. Okay, no, this is plus become minus here, wait, so actually this will be log 21 minus log 36 because 6 ka square 36, so that become log 21 upon 36. So both comes in 3 table, 3 7 ja, 3 12 ja, so that become here log 7 upon 12. Okay, now this x we need here, so x is equal to log 7 upon 12. Okay, this will be again, this is what, now everything will go there, we need only x cover, so this is multiplication, come become division upon log 6. So the answer is x is equal to log 7 upon 12 whole thing divided by log 6. Okay, so this way we have to solve. Let's do one word problem also and then we'll stop the chapter. Okay, so now the next sum we have 9 raised to x minus 4 is equal to 3 raised to x plus 1. We have to solve this. Okay, so this is little bit different type ka sum, so that's why I'm making this one. So 3 raised to 2 the whole x is equal to okay minus 4 is equal to 3 raised to x into 3 raised to 1. Okay, so you can say now, so that you have to change that 3 raised to x raised to 2 minus 4 is equal to 3 into 3 raised to x. Okay, still we cannot solve directly, so we'll do here, let 3 raised to x is equal to a. Okay, we have to substitute here something, so that 3 raised to x is a, so this become a square minus 4 is equal to 3a. So a square minus 3a minus 4 equal to 0. Okay, so now we have a square, the sum and product rule, so a square minus 4a minus a plus a. Okay, minus 4 plus a minus 4 equal to 0. So a minus 4 plus 1 a minus 4 equal to 0. Okay, so a minus 4 plus 1 a minus 4 equal to 0. So a plus 1 and a minus 4 equal to 0. So a is equal to minus 1 or a is equal to 4. Clear? Now once you get a ka value minus 1 or a ka value 4, we have to resubstitute because actually we have to find the x ka value, not the a. So we have to write here, therefore 3 raised to x is equal to minus 1 or 3 raised to x is equal to 4. Okay, now how to solve 3 raised to x is equal to minus 1? So we have to go to the log chapter. Log mein what we did here? So log minus 1 to the base 3 is equal to x. Log answer to the same base is equal to the power. Okay, or log 4 to the base 3 is equal to x. So log of any negative number is not possible, so this is not applicable. So x is equal to log 4 to the base 3 is the final answer. Okay, log 4 to the base 3 is the answer. Okay, same way let's do one word problem also. The sum is given, the number n of bacteria of after t hours is given by formula n is equal to 16,000 into 1.6 raised to t. Okay, the equation is given what? N is equal to, this is what? This is the formula given, n is equal to 16,000 into 1.6 raised to t. 1.6 raised to t. Okay, so now they are asking find the initial number of initial, whenever they ask the initial number, replace t ka value 0. Okay, t ka value 0. Okay, if they ask the after 1 year, so t ka value 1, they given after t hours, so initial meaning directly the same point, current point, same time, so that t will be 0. So for the a part, n is equal to 16,000 1.6 raised to 0, and anything raised to 0 is equal to 1. So 16,000 into 1 is equal to 16,000. So what is initially, how many bacteria are there? So initially there are 16,000 bacteria in the given. Okay, next one is find the number of bacteria after 4 hours. Okay, so now first the formula, n is equal to 16,000 into 1.6 raised to 4. Okay, now raised to 4, either we can solve directly by using the normal calculation. What you can do here, we'll do 1.6 into 1.6 into 1.6 into 1.6. okay, 4 times 16 ka square, and again that ka square you can do to get the answer, and then you have to put the point before 4 number. Okay, but since we are doing the logarithm chapter, we can solve by using the log book also. Okay, log book also we can solve this. Okay, so we have the log book also. Okay, so this is the log book you get in the exam also while solving, but this is our own. Okay, the school, college provide their own log book. Okay, so this is normally they give in the 12th standard में, but suppose you are from the A level mathematics or from the IB or from the additional maths, so then you will get the calculator, so you can directly substitute this value in the calculator, you will get the answer. Okay, so here we can say, actually instead of doing with the log, because the log is like you have to see you can see here there is a logarithm things. Okay, so we have to use the formula here 16,000, then we have to do, so if you go with the log, so we have to take the log and anti-log, and this is a big process. Okay, we'll do this in the one separate lecture mein, how to solve by using the log book, but here directly we are doing with the. Okay, so instead of the log book we are using the calculator, we are using the this scientific calculator for this to solve. So 16,000 into 1.6 raised to 4 will directly put in the calculator. 16,000 into 1.6 raised to 4. Okay, so we'll get the answer 1,04,000. Okay, this is what 1,04,857.6. Okay, so we can solve this by using the log book which I just shown you, or you can solve with the calculator, but nowadays they stopped giving the like for other board, only for Maharashtra board mein they give the calculator, other board mein they give the calculator after 12th, and IB, IGCSE and A level mein they give the calculator from the grade 9 for solving this type of sum. So if you do estimated value, so that become 105,000, so it will be nothing but 1,05,000 bacteria will be there after 4 hours. Okay, same way find the value of the T when there are 20,000. Okay, 16,000 is the starting, so 20,000 will very small amount come. So let's solve how to do this. So we have to do 20,000 is equal to 16,000 into 1.6 raised to T. Okay, T, not N in this case. Okay, so the first thing 16,000 will take this side, so this become here 20,000 upon 16,000 is equal to 1.6 raised to T. So 1 2 3 1 2 3 4 ja 5 ja 5 upon 4, you can say 1.25 is equal to 1.6 raised to T. So that become here the log 1.25 to the base 1.6 is equal to T. Okay, again you can put in the calculator mein. So we have the log to the base 1.6, okay, with 1.25. okay, this is all everything there in the calculator mein, you can just put, you will get the value. So T is equal to 0.4747. okay, 0.4747. so T ka value 0.47 hours you can say. Okay, so 0.47 hours. So this way we have to solve the what problem, normal log ka sum. Okay, now more difficult sum will do. There is a logarithmic function also come, exponential function comes. So in that way we'll do more details. May as of now we are stopping here. So we did the whole surd, indices and the logarithm, and all they are correlated. So that's why we kept it in one video. Okay, for other things you can again just like and subscribe my channel.